This is Immuno Africa, a podcast dedicated to spotlighting African immunology research.
The first edition of the Immunology in Africa podcast graduate student series seeks to spotlight the motivations, journeys, and perspectives of African graduate students in immunology while highlighting their amazing contributions to the field. It offers our listeners an opportunity to explore and keep tabs on the inspiring works of young African scientists in the early phases of their careers, especially those keen on strengthening the continent's capacity for scientific research, growth, and development. For this first series, we spoke with 6 graduate students pooled from 5 African countries whose research spans a rich diversity of viral diseases, vaccine development, cancer, obesity, autoimmunity, and allergies. The stories told here portray self-motivation, initiative, resilience, hard work, excellence, consistency, growth, discipline, planning, and patience. These stories offer valuable insights and lessons to young and emerging scientists interested in building a career in immunology, as well as established scientists in the field. In the second episode of this series, I speak with Doudou, George, Massar, Niang. Doudou grew up aspiring to be a professional basketball player, but he is now enamored with the field of immunology. How did he get here? That we'll soon find out from him. With a Doctor of Pharmacy and 2 master's degrees from Cheikh, Anta, Diop University, Doudou's background spans hematology, cancer immunology, and genetics. He has spent the last 4 years of his PhD understanding the roles of Gal-3 and various cytokines on triple-negative breast cancers. The overall goal of this study is to explore how Gal-3 might be used as a biomarker and therapeutic target in various malignancies, particularly breast cancers. In this episode, he shares some of the interesting findings he has made so far and the implications they hold for breast cancer patients in Africa.
I'm from Senegal, Dakar, that is the capital of Senegal. And I spent my whole, I grew up here. And I went to high school and university here. My high school was named Doudou, Lycée Doudou. And from that high school, I made my final year of high school in another school that were more close to home, that is called Blaise Diagne. And after that, I came to Cheikh Diop University, where I did start with pharmacy school. I wasn't supposed to become immunologist when I began, and I was even supposed to become a scientist because my main objective was to become a professional basketball player.
Wow.
I did play basketball for 14 years before being forced to stop due to a conflict between my schedule at university and the schedule with our basketball team. Mm-hmm. So my dream was to become a professional basketball player, and I like to say that I'm scientific by accident. So I start pharmacy school, and during my 3rd year of pharmacy, I had my first contact with immunology, and I was like, wow, I'm also passionate about history. I watch a lot of documentary. I read a lot of book about history of different continent and countries. So I was like listening a story about medieval heroes that were fighting for saving their country, and it is something that catch my attention with immunology. And that year, I decided to make it a purpose for me, became an immunologist. It's how the things are. So I finished my pharmacy. I got a grade. I'm doctor in pharmacy, and I also became medical resident in clinical biology. So I had to spend 5 years in hospital lab making routine analysis. And in parallel, I did start a master degree in immunology, which I got in 2018. And then I start a master degree in genetics and my PhD in immunology. So currently, I'm not medical resident anymore. I did finish last year. I did finish my master in genetics as well, and now I'm trying to finish my PhD.
Oh, wow.
Yes.
So I think for someone who wanted to be a basketball player and then you're so invested in learning now, I think it's really a great transition. So like I'm just really surprised, pleasantly, of course, that you've already done 2 masters. Yeah, and you're already wrapping up your PhD. So, but I think I think I'm tempted to ask, like, maybe you should provide more details about how you got interested in the field of immunology and what drew you to the field? You know, what was that interesting part? Like you already mentioned that it was in your 3rd year, and then you talked about history, some historical books or documentaries you were exposed to. But let's go into the nitty-gritty of how you got interested. What in immunology sparked your interest that made you to, I don't know if you've abandoned it yet, but that made you abandon your dream of becoming a professional basketball player?
Okay. So first of all, with immunology, at the start it was curiosity. We had excellent teacher that made the science very accessible to us, and during the time I've noticed that it's a very quick changing field. As an example, when we were learning immunology in that time, they were teaching us that the only cells that are antigen, professional antigen presenting cells,
yeah,
are dendritic cells. That is the only one that is able to make cross presentation. And in the past few recent years, they did discover that gamma delta T cells are also able to do that. Gamma delta T cells that were cells that we had only 1 minute about gamma delta T cells because they were unknown in that time.
Yeah.
So it's a very quick changing field, and you don't have time to get bored.
Interesting.
Every day there is something new, and I'm someone that I found that I easily get bored. I had to work in a drugstore as pharmacist. I had to work in a routine lab, and that thing of doing every day the same thing wasn't for me at all. And the fact that immunology is a constantly changing field is something that I like.
I really love that story. So so you I think you first mentioned the fact that you're a very curious person and then you don't like to get bored. So immunology was like the perfect haven for you. There are lots of findings and so many things to still discover about immunity in humans and even animals and various organisms. So yeah, lovely story you have there. Yeah. But I think I should first find out, like, what made you want to do a master's in genetics before I ask about your work generally. So what spurred you to do a master's in genetics?
Okay. I'm more interested in cancer immunology.
Okay.
And there is I found that genetic And molecular biology could be an interesting tool to apply on study of cancer immunology. Yes, that's why I went to yes, I did this master for acquiring knowledge that I will be able to apply then
to your field.
To my field, yes.
Yeah. Okay. So what have you been doing so far? So you're already wrapping up your PhD program. So what findings have you made so far, trying to blend the fields of immunology and cancer and genetics? Yeah.
We are currently working on Galectin-3 involvement in cancer, and more specifically in breast cancer. And Galectin-3 is an interesting protein because it's involved in many biological processes within which some biological processes that are related to immune response. And from the literature, many in vitro and in vivo studies have shown that Galectin-3 can have a pro-tumoral effect because, as an example, Galectin-3 can induce T lymphocyte apoptosis. Galectin-3 can favor switching of macrophage phenotype from M1 phenotype, that is anti-tumoral phenotype, to M2 phenotype, that is a pro-tumoral phenotypes. And so there is a lot of examples like that of proof that have been made in vitro and in mice model of Galectin-3 conspiring with the tumor to manipulate immune response to make it inefficient against the cancer. And what we found also interesting is from the literature, the molecular subtypes of breast cancer that is known to overexpress Galectin-3 is the triple negative one. And in West Africa, we have a lot of triple negative breast cancer. There is controversy about those data, but there is studies that have shown that in Senegal, the rate of triple negative breast cancer is 46%. In Ghana, it's almost 60%, what is a lot in westernized country, in Caucasian people, it's less than 10%. They have more estrogen and progesterone positive breast cancer that are luminal R or luminal B types. So Galectin-3 could be overexpressed by the tumor we have more here that are more aggressive, that progress very quickly, and that have very poor outcome. So since Galectin-3 is has a pro-tumoral potential, if our hypothesis is Galectin-3 is involved in that aggressivity of triple negative breast cancer. So what could make it a prognostic marker and also a potential therapeutic target, since there is Galectin-3 inhibitors that have been developed that are less expensive than molecules like trastuzumab that we use to target breast cancer that express HER2 receptors. So this is why we had this interest for Galectin-3. And what we did first, currently what we are trying to do is generating enough, with my supervisor, is generating enough preliminary data to get a grant to push forward. And what we did with my PhD is, first we recruit patients with breast cancer before any therapeutic intervention, and we took blood sample from them. We assess Galectin-3 plasmatic rate, lymphocytes activation, and apoptosis, and we found that Galectin-3 was higher in patient compared to control, with a positive correlation between Galectin-3 rate and tumor size. The more tumor is big, the more the Galectin-3 rate is high. But we did not find relationship between galectin-3 rate and lymphocytes apoptosis and activation. So it is our most interesting result. And what we did beside is, since we were thinking about making galectin-3 a biomarker, we had to make sure that it's accurate biomarker that isn't influenced by something else than the disease. And we know from the literature that galectin-3 has blood group antigen as ligand. And we tried from a blood donor. We took samples from blood donor to see if there was an influence of blood group antigen on galectin-3 plasmatic rate. And we found that people that express A, B, and AB antigen of blood group have lower galectin-3 plasmatic rate in non-pathologic condition. So what we want to do next in the future is, since we did assess galectin-3 in the peripheral blood, and we assess the lymphocytes apoptosis and activation in peripheral blood, we want to go inside the tumor and see what's happened there in terms of galectin-3 expression and its influence on immune response.
Okay, thank you. I think that's a lot. So I will start from the last thing you said. So basically, the study so far you've done, you were measuring the level of galectin-3 in blood samples, right? So in the future, you want to really access the tumors and measure the level of galectin-3 in those tumors. A really interesting part of your study is its relevance to the African setting, that it's highly expressed in triple-negative breast cancers that have a relatively high prevalence in Senegal, in Ghana, and perhaps other African countries too, in comparison to, the global north or other individuals like non-Blacks or non-Africans. And then you said that the galectin-3 conspires with the cancers to, aid cancer growth, cancer progression, right? And that you are looking at it to study how so use it to measure how the cancer is progressing, because you observe that the size of tumors and the level of galectin-3, there's kind of a correlation. So the larger the tumors, the higher the level of galectin-3. And then you're also looking at using galectin-3 as targeting it, the protein with molecules that are apparently cheaper or more accessible than the very, very expensive cancer therapies we make use of now. Like, I think you mentioned an immunotherapy, a monoclonal antibody used to treat cancer. Interesting. Like, I think I'm already enjoying the conversation, right? Because my next question was supposed to be, so why is your research important? What's its relevance to the African populace? But I think there are already points that you've mentioned about about the triple-negative breast cancer, and then also about the fact that the therapies that you'd probably develop in the future will be cheaper than some of the current therapies. Like, therapies that can target galectin-3 will be cheaper than the other therapies we have used to treat cancer today. So yeah, so I think you should just talk a bit about triple-negative breast cancer.
So in breast cancer, there is molecular classification of cancer that rely on expression of three receptors that are estrogen receptors, progesterone receptor, so a female hormone receptor, and beside human epidermal growth factor receptor 2, HER2. And the tumor that express female hormone receptor and that do not express HER2, they are classified in either luminal A group or luminal B group of breast cancer. And when the breast cancer express only HER2, it is considered as breast cancer overexpressing HER2. And when the tumor do not express those three markers, it's a triple negative breast cancer. And in terms of prognostic, grade of the disease and aggressivity of the disease, triple negative breast cancer are very bad because they have high grade, high aggressivity and poor outcome. And there is currently no targeted therapy for triple negative breast cancer. And there is targeted therapy for the other molecular subtype, but no for triple negative breast cancer.
So thank you for that, providing that simple explanation to what the triple negative breast cancer is about. So I think, like I said, you already highlighted how there are already aspects of your research that relate to, the unique context of the African populace. But I think I will still give you a few minutes to just expound on it, on how you think your research is relevant to Africa and how it will benefit Africans. And yeah, so I think that's just my question. So how is your research relevant to the African context, and how will your research, these findings, and then, the possible applications, the translational aspect of it, how will it benefit Africans?
Okay, I think that maybe we are a bit far away from the potential future application, but our main objective was to, since we have seen that there is some disparity in cancer. The incidence of cancer is higher in high-income country and westernized country, but the mortality, the lethality of those diseases are higher in our context.
Mm-hmm.
There is socioeconomic explanation, access to health. There is a lot of socioeconomic explanation, but there is fact that the socioeconomic factor doesn't explain. As an example, why do we have more triple negative? Maybe it's because we are exposed to some environmental factor that doesn't exist in other countries, or even infectious disease that doesn't exist in other country. But it can be also due to our genetic background, since there is a lot of heterogeneity in terms of genetic within our continent. So our purpose is to identify those specificity in terms of immunogenetics, to try to target them to improve the care in breast cancer. And with regard to the fact that every therapeutic intervention we will try to bring in the continent should take into account that it should be accessible as possible. So with our project, we are trying to find something that could be targeted, that is specific to African continent. Mm-hmm. And that could be used both as biomarker to predict outcome of the disease, and also could be targeted to improve patient outcome with higher accessibility.
So basically, you're looking at the fact that the African populace, there's this heterogeneity in our genetics, and then whatever you're targeting should be accessible, should be relevant to that context, and then it should also be accessible. Maybe accessibility regards access itself, and also regards the financial accessibility, and also it should also serve the dual purpose of being used for kind of prognosis or diagnostic goal, and also relevant to being a drug target. I know you mentioned that you're doing a lot of writing, and you have deadlines to meet. So, but while you were doing all of this lab work, so what was the typical day for like you in the lab?
Okay, and it is an interesting question, and there is rarely 2 days that are the same our in our it's difficult to find 2 days that are the same. Usually, in the morning, I'm supposed to be at hospital because I'm also a medical biologist. I'm working in a military hospital of Wakam. And during the morning, I'm there. And during the afternoon, and the evening, I'm here at our university lab. And sometime we are working on a side project with my supervisor. Sometimes we receive call for recruiting patient, and we have to travel toward all the hospitals that are in Senegal for recruiting those patients. So during the morning, it is mostly routine and routine lab work, and during the afternoon it's more research. And sometimes during the morning, it's happened that we have to recruit patients and go in other place for meeting those patients.
So, what kind of experiments did you run for this study?
So for this study, we did ELISA. We did also we did assess Gal-3 cytokines, pro-inflammatory cytokines, and IL-10 by ELISA sandwich. We use flow cytometry also to characterize T and B lymphocytes and assess also the activation and apoptosis rate of those cells. I'm actually trying to write the thesis to finish this year, but there is a part that is more molecular biology, for which I'm currently extracting DNA to run some PCR experiment for genotyping of interesting gene variants that could be involved in high Gal-3 trait and expression.
Yeah, cool, really cool. I think, like I mentioned, your background in genetics and immunology just gives you that foothold, really strong foothold to, explore various aspects of your study. Because I think for someone who did not have a genetic background, they probably just focus on the immunological aspect. And for someone who don't have an immunology background, they focus on the genetic aspect. But since you have background in both, you can understand the genes that are influencing the immunological aspect, and also understand how the immunology is contributing to the disease. So yeah, I think I'm just curious to ask about studying in Senegal. So was this like a funded program, or were you self-funded, or was it a scholarship?
It wasn't a funded program. I had a chance to find all the project that was ending, and they had a region that were left, and from that we organized to build this project and to start. And during that time, I did meet with one guy that became a friend in an immunology congress in China. His name is Jacobus Hendricks. We discussed about the project. He was interested, and we start working together. And we obtained a small grant in South Africa for the genetic part of the Gal-3 investigation. And now what I'm doing is using all those results to try to build a grant to get more fund. Research here is it's difficult everywhere, but we have some challenges that are specific to us. As an example, to learn multiparametric flow cytometry, I had to move in Gambia to have training, a 1-month training there, because during that time there wasn't a good flow cytometry facility in our country. And the main limits that we encounter is technical facilities.
Okay.
So it's challenging for learning techniques and also even running experiment.
I think I had to ask that question because I know doing a PhD anywhere in the world is already difficult, but then doing it in Africa is, I think, it's another level of difficulty. So yeah, so I think from you're able to secure a small grant, right, to support your work, but I think it was also largely funded by you, and maybe you got support from your supervisor, right?
Yes, my supervisor.
Okay. So because oftentimes when Africans leave the shores of the continent to other countries, most times, in most cases for PhDs, is usually funded programs. Maybe the supervisor or the university, or maybe they secured a kind of independent scholarship to fund their work. But then doing it in Africa, they are already I wouldn't say they are really funds, but they are actually really funds. Like maybe you don't, it's not typical to have multiple funded PhD programs for people who are doing PhDs or even MScs. Most times you have to, be working alongside your program so you can secure funds to keep the project going. And I think that's one disadvantage Africans, face sometimes. Someone was saying recently that if you're using the same brain to think about money and think about research, your thoughts for the research will not be coherent because some of your brain cells are already focused on money, and then the few ones left will not have the capacity to bear the kind of thoughts and ideas that will take your research forward.
I would like to encourage all young immunologists to go on Immunopedia. Immunopedia is a platform that is amazingly helpful for young scientists. There is a lot of interesting course material that is available online, but also there is a lot of opportunity around Immunopedia. You can become an Immunopedia ambassador to help to it will help you in many aspects of your career, and it help also to be on touch with immunology events that are organized in the world and within the continent. My first real contact with the research, the world of immunology research, was thanks to Immunopedia. Frequently, the educational committee of IUIS organize a course for which you can be candidate, and when you are selected, they fund you to travel. You meet amazingly kind and good scientists in the field of immunology. You have occasion to learn and also to make networking and to obtain opportunity. So I would like to encourage all young immunologists to subscribe to the Immunopedia newsletter. It is amazingly helpful.
Thank you. Thank you for mentioning that. Yeah, I think I know about Immunopedia. I've explored their website too. So, and I think it has lots of resources like you shared. So I think the next thing I want to ask about is, for someone who has spent 4 years or more, at least minimum of 4 or 5 years, or maybe 6 years in graduate school, you would have had waves of successes and failures, unmet expectations. Maybe you applied for something and then you didn't get it. So what's your approach to celebrating wins or handling rejections?
It's a very tough one because since I started in university, I don't remember having really celebrate success, because every time you finish something, you have to be focused for the next step. But usually what I do, the first thing I do is sending or calling my mom to tell her, and usually the celebration is mostly with her.
Okay. So what about failures or rejections? How do you manage them?
Failure is painful, but I'm very faithful in God. And what I usually say is, when He do not give you something, it is because it wasn't the best for you, and He's keeping something best for you. So usually I don't complain a lot, and I don't stay sad or affected a long time. I just say that it's God will, and since it's God will, it's not the best for me. Maybe there is something better. Yes.
I think that's a nice perspective. So thank you for sharing. So you really do not celebrate success like that. So like typical celebration. So you call your mom, and then I would say celebrate with your mom. But then for failure, I think you have this confidence that if you are not getting something, then it means God has prepared or is preparing something better for you. So I think overall you don't dwell too long on successes or failures. So you get over them quickly, and then just move ahead to the next task. Yeah. Something else I wanted to ask about is particularly in the context of your research, or maybe your experience generally outside of research. What's something you think you would like to change if you had the capacity to? Perhaps you became the president of Senegal today, or or perhaps you are in that position where you're able to inform certain policies, maybe in research, in science, or in any area. Or what are things that you think the continent has to give attention to, maybe in the context of immunology, but perhaps in the general context of science and research?
Okay. I have one from my opinion. As you said previously, there is a lot of it's very difficult to have opportunity for PhD and postdoc within Africa. And I think that for the next generation African scientists, it's our responsibility to try to change it. And how? At one point of our career, some of us got opportunity to travel and learn how to do good research abroad. And then at one time, I think that we have to think about giving back to our country. It's our responsibility to try our best to create opportunity for the young scientists that will come next. So if I was able to change something, I would do it as scientist and try to create as much opportunity as I can for young future immunologists that are in Senegal.
Yeah, thank you so much for that. So I think your primary concern is the availability of opportunities in your country and also in the continent, and you believe people who have, individuals who have had experience, international experience, should be willing to take it upon themselves to give back to their home countries, to give back to the continent, and ensure that the coming generation, they do not encounter as much stress as the current generation is experiencing. Yeah. So I think that's really a very important issue that deserves lots of attention in the continent, right? Creation of opportunities, multiple opportunities, because if we want to bring in the conversation of brain drain, that context of course, people are already arguing that it does have its benefits, but the whole idea of people leaving the continent, if there were opportunities, sufficient opportunities, perhaps people will still be living, but maybe not as much as the number of persons who live now. But yeah, so I think that's something really important about creating opportunities. And I believe, like, perhaps with your experience and of course with what the future holds for you, I have no doubt that when you are in that position of power or authority or influence, you would be more than willing and capable to make sure that people have access to opportunities, and there is this abundance of opportunities for young people and of course for individuals in the continent. The next thing I wanted to ask before we take the last part of the interview is about your life and your journey, your experience. So what are the things you think guide you as an individual?
Okay, my mindset is I see life as quality management. In quality, we say that it's I don't know how to translate it in English without changing the sense, but it's a permanent improvement. So as a human being, we all have limits, and we have to stay and see where are our limits. It's the diagnostic, and when you have your diagnostic, all your life long, your objective should be to try to improve yourself again and again and again and again, all your life long. And it's I'm applying it to all the part of my life, either in the professional part of the life, the personal life, and even in terms of faith. We are not perfect. We all human sin, but since you know it, you have to try your best to improve yourself every day.
Okay. Yeah. So you said quality management and, constant improvement. So making sure that every day you are striving to become a better version of yourself, and you try to apply it across every aspect of your life, in research, in academics, in your faith. And the last question I want to ask now is what your favorite immune cell is. What's your favorite immune cell, and why is it your favorite immune cell?
Okay, thanks to Prof. Dieter Kablitz that have met in one IUIS course. Since that time, I'm a huge fan of gamma delta T cell.
Oh, okay.
Before that course, it was the Immunology course that was about allergy diagnostic and therapy in the molecular era. And he did an amazing presentation about gamma delta T cell. And I've seen that those cells are able to do everything. They are cytotoxic. They are able to secrete cytokines to regulate immune response. They are antigen presenting cells. So they are doing pretty much everything. And something that amazed me also is T cells need to recognize antigen. So protein, you need mutation in a specific gene that will change the protein in cancer context for the T cell to recognize it. But the gamma delta T cells are able to sense metabolic changes, what is also amazing. So I'm a huge fan of gamma delta T cell.
So I think you're almost converting me to also love gamma delta T cells. So so I'll probably go. I think I've seen them somewhere before, like that name. But so I think I'll probably go and maybe do some reading about gamma delta T cells, and after this call, so let me also explore their this unique and amazing feature they have. So what's your plan after your PhD? So are you staying back for a postdoc in the continent? Are you going into industry, or are you exploring opportunities outside the continent?
What I would like to do is to try to obtain internship first in good research institute. I feel like there is few things I need to set up and improve myself with those before candidating for a postdoc. A postdoc abroad to learn as much as I can about how to manage research before coming back in Senegal, and try to create opportunity, as I said, for the people interested in immunology here, and then try to promote and push immunology more forward in our country.
Yeah, so I wish you the best with that. Yeah, I think of course I love the perspective of your response relates to your perspective of constant improvement, right? So you still see a need to own your skills in the field before delving into a postdoc. I do pray you get all the support you need and become that kind of researcher that you've always dreamed of. So thank you so much once again.
Thank you very much for inviting me, and I wish you also the best with your podcast series and also your scientific career.
How did an aspiring professional basketball player end up as an inspiring immunology scientist? Well, we all know that story now. However, that's just one way to view Doudou's journey. Another equally interesting and stimulating perspective will be how context-specific and promising his proposed solution to targeting the aggressive breast cancers found in Africa is. We also have the answers. We are excited about what the future holds for him, and we'll keep you all posted.
Thank you for listening to this episode on Immuno-Africa. If you enjoyed it, please feel free to share it with your network. You will learn first about future episodes and get other immunology-related updates by following Immuno_Africa or the Immunology in Africa podcast on social media. See you on the next episode. Bye.